Number 6, a student pushes a box across a horizontal surface at a constant speed. So we have a constant speed of 0.6 meters per second. Box has a mass of 40 kilograms, and the coefficient of kinetic friction is 0.5. Power supplied to the box by the person. All right, so we do know that power equals work over a change of time, but we also have another derived equation where we have power equals force times velocity, as long as the velocity and the velocity and force are going in the same parallel to one another. All right, so let's see. We do have the velocity. We have to come up with the force. All right, so if we know we're moving at a constant speed, we know the acceleration has to be 0. Right, so we have a box moving this way. We have an applied force, and we also have a force of friction opposing it, and constant speed acceleration is 0. So summation of forces equals 0 because of the constant speed. There's no acceleration. We have force applied minus force of friction equals 0, or the force applied equals force of friction, right? So the force applied equals mu k mg, right? So we can come up with that by saying force applied equals mu k, which is 0.5, times a mass of 40 times g, which is 10. So force applied, 400 times 40 times 10 is 400. Half of that is going to be 200 newtons. So going back to our original equation, we could plug in 200 newtons times our velocity of 0.6, and we're going to get a power of 120 watts.